it's very important when we talk about the power of women in the community that we think of women are not just contributors. It's not just about the gender gap. It's about how we empower women to be the drivers of innovation, to drive that inclusivity and that critical global impact.
Well, this is not a surprising fact that women currently make up less than 30% of the tech workforce. But what's more important to know is that even though we have a small representation, yet our perspective and talents are essential for building inclusive products and diverse teams.
As we look to the future, it's clear that empowering women in tech is not just a goal, it's a necessity. And by supporting and encouraging women to pursue careers in technology, we are building a stronger, more innovative and inclusive industry.
This is an opportunity to reconsider how women can be those bold leaders who can really inspire the next generation, who are showing those young girls what an amazing path it can be to find your place in STEM careers, to have that kind of role model and voice that can really support that diversity, not just in gender or thinking, but in non-linear career paths, and how we can really champion that through the Microsoft community, to really lead with empathy and to show how technical expertise and innovation knows no gender.
Well, hey everyone. I hope you are doing fantastic no matter where in the world you are joining us from. Welcome to another inspiring session as part of Women in Tech Month here at Microsoft Zero to Hero community, your community. I'm Saeed, and it's an absolutely honor to host today's session with all of you. So together, we built something truly remarkable, a community that has now grown to over 7,000 members. That's over 7,000 members, experts, learners, and Microsoft enthusiasts, united by a shared passion for technology. Regardless of location, age, race, or gender, we are here to lift each other up, share knowledge, and create a space where everyone can thrive. So let's keep the momentum going. Without further ado, let's dive into today's session. So as usual, I have my presentations here. So perfect. Yeah, today we have incredible guest, Teena. Teena is a senior solution architect at Microsoft, and her expertise in building scalable, cloud-native, event-driven architect is pretty much well-known. Behind her technical powers, she's deeply passionate about exploring the potential of quantum computing in finance. As a public speaker and dedicated mentor, Teena actively empowers young minds and women in tech, inspiring the next generation of innovators like you. In today's session, Teena will dive into a fascinating and high relevant topic, building a global distributed scalable serverless application. This topic is not only exciting, but also crucial in evolving world of technology when you are going to have a cloud application or cloud solution in Azure environment. So about Microsoft Learn Community. Microsoft Learn Community is a place where people from all over the world can connect together with learners, technical experts, and build important skill and work toward their career goals. And it's not only that. So basically, when you join Microsoft Learn Community, you can leverage the power of connection between experts, learners, and even you have this opportunity to share your knowledge with the other learners. And Microsoft Learn community has many Microsoft Learning rooms. One of them is Microsoft Zero to Hero. So if you would like to be part of Microsoft Zero to Hero, aka.ms/join Zero to Hero is the short link of the community. So you can easily use that, fill it out the form, and after 24 hours, you will be part of the community. Also, you can follow us on YouTube and LinkedIn, where we are sharing about all information related to sessions, stories, and so on related to the community. Beside that, if you would like to check other learning rooms, you can go to this short link, aka.ms/learning rooms. And if you would like to learn more about Microsoft Learn community, aka.ms/Microsoft Learn community is the short link for that one. So we are in Microsoft. We are in Women in Tech month. So far, we have had some sessions, and today we have Teena on the stage, and also soon we will have Emily and Michelle for 2 next sessions. Make sure that you have registered for 2 next sessions as well. We are going to support each other and learn from these amazing experts, not only from technical side, but also about what they achieve in their life and how they, getting success in this learning journey. So the last slide of mine, it's the code of conduct. So we want you to be aware of others, be friendly and passionate, be welcoming and respectful, be open to all questions and viewpoints, be understanding of differences, and be kind and consider the others. So with that said, I'm going to bring our amazing speakers, Teena, on the stage. Hello, Teena. Very welcome to Microsoft Zero to Hero community stage.
Hey, hi, Saeed. Thank you for the very warm welcome. I'm very excited to be here and especially representing the Women in Tech Month. So thank you for inviting me.
Yeah, thank you so much. Thank you so much. Teena, you are pretty much active in Women in Tech. So as a person, as an active person in Women in Tech, what do you have to share with our audiences in like one sentence about power of women?
About power of women, yes, I think I'll just reiterate what I even spoke in the video, that even though we represent a really small number in the tech workforce today, it's 30%, it's less than 30%, but still we all have our diverse and unique perspectives and ideas that we bring to the table. And I think we have a lot to offer, and together we can achieve whatever we want to achieve.
Yeah, exactly. That's true. That's true. But yeah, thank you so much again for the voice that you sent for us. For those people that they don't know, the intro video that we have for entire sessions in Women in Tech Month, we ask our amazing speaker like Teena, Angeliki, and Michelle to share their voice, their inspirational words with us. So the voice that you are hearing is Teena, Michelle, and Angeliki voice. So thank you so much. Perfect. So with no delay, let's start the session. I'm going to bring your slides up, and yeah, good luck.
Sure. Okay. So thank you. Hello, everyone. I want to give a warm welcome to all of you joining today from all over the world, across various time zones. A very small introduction about me. I think everything Saeed already mentioned, but just telling it again, I'm Teena Idnani. I am a senior solutions architect based out of London. I have recently joined Microsoft, actually just completed a month yesterday. Prior to this, I was a senior VP at JP Morgan Chase, where my role was to help build the Azure platform at the bank and enable various teams as they migrate and modernize their applications on Azure. I have worked extensively on event-driven architectures, and I wanted to share my learnings with a broader community. I have spoken at a few other conferences and meetups about event-driven architectures and distributed applications. So here I am Today, I'm going to be talking about building these globally distributed, scalable, serverless applications on cloud. And just a disclaimer, the opinions and experiences that I'll share today will be are mine, and they do not reflect my employer. I'm also, as Said mentioned, I'm very passionate about exploring potential applications of quantum computing, especially in the finance area. And I try and speak regularly at technical conferences, and I enjoy mentoring young minds or women in tech. So let's dive straight in. So now, whenever you talk about building globally distributed scalable systems, there are different quality attributes that we commonly try to achieve in modern software architecture. Like we want it to be cloud native, we want to build reactive systems, they should be scalable, high performing, it should have high availability, low latency, we want loose coupling, agility, and so on and so forth. And of course, how can I forget cost efficient, right? So ultimately, we all want resilient systems that can basically withstand surges, failures, and attacks without compromising on data integrity. But what we need to understand is that getting these quality attributes in your application, it's not an easy job. There are challenges. And to understand these challenges, let's look at one common scenario. Let's imagine that we are building an e-commerce site and we have a customer who places an order. And now, off the back of this placing order, now few other actions need to happen. Let's say a delivery needs to be done. You need to have a payment. You need to have a notification system. And let's see how these components can be connected with each other. Now, in a synchronous architecture, the application will handle each step before moving to the next. Like you'll notify the customer that the order is received, you'll request the shipping to package the order and deliver it, and you'll also send a payment transaction. And each step blocks, and it must finish before you can move to the next step. So you can say, it's tightly coupled, less flexible. And what would happen, let's say, if the notification to the customer errors out and it fails? Now, because it's a synchronous architecture, it might block the entire workflow. Like the order processing would stop until the notification issue is resolved, and no other steps like the delivery or payment will be able to proceed. And you can kind of say that the entire application is blocked by failure in one component. And even like if you take another example, if the payment step is delayed, like similarly, or it fails due to a timeout, the entire workflow is blocked. So now I'm realizing that I'm probably oversimplifying this massively. We know that there are ways that you can build synchronous systems that can handle these problems, like using circuit breakers or exponential backoff or using proper handling. And just because you are building a synchronous microservice system, it doesn't necessarily mean that your system is going to be unstable. I think the point that I'm trying to raise here is that you are responsible for the constraints that other system has. And you need to work around the constraints that the system you are calling imposes on you. And this basically, you can say that these are the challenges with that these synchronous architectures that they pose, like latency and delay, because you have to wait for the responses before you continue. So it can impact your overall throughput. You have a lot of tight coupling. So the components are very tightly coupled together using these request response methods. So this reduces flexibility and it makes it kind of harder to reuse or replace components. You have cascading failures. We just saw in the previous example that a failure in one component has the potential to block others from proceeding. So, this can cascade across the entire system. You need complex coordination, like ordering, timing of the things, synchronization between components. You need to handle error handling. And I'll say it's more hard to handle partial failures and errors gracefully without propagating them. And then even scaling is a difficulty because it's basically all tightly coupled. Then you need to scale matched pairs or clusters of components. Okay, so this is where event-driven architectures, they come to the rescue, which we will talk in our rest of today's session. But before we go to that, I just want to level set to make sure that we're all on same page with a little bit of theory, to get us all aligned to event-driven architectures. So let's dive into that. Like, simple thing, what is an event? Now, in the simplest of terms, an event, it's a signal that a system state has changed. Okay, it's an immutable fact, which means that because it's something that has happened in the past, you cannot change it. And then it's lightweight. So it basically, I'll show you the schema of an event. You'll notice that it includes some common properties across the different business domains with IDs for more details at the source of truth. Then, yes, a very important thing, events are facts, everything else is opinion. Now, this is really important because events, they represent things that have already happened, and this will be very beneficial when you come to naming your events, which is our next slide. And coming to naming these events, basically, events have this semantic intent represented as verbs in the past tense. Okay, so for example, order created, or payment initiated, or order shipped. So these are the kind of things we need to remember when we are naming these events. Now, one thing that I have noticed a lot is that people often confuse events with commands. And it's very important to kind of know the distinction between the two. And let me tell you that events and commands, they are very similar. And the difference is mostly just a statement of intent. Like, am I telling a system to do something? Or am I reacting to something that has happened in another system? Okay, so the first is command and the second is event. So commands basically tell the components to do something specific, and they are very tightly coupled. Okay, like in this example, please send an email confirmation. Okay, it is sent. Whereas events, they simply broadcast data about something that has occurred. Like, for example, in this case, Alice has ordered a phone. And what we are really interested in, it is in the observable nature of these events. And why is that so? Because event producers, they don't need to have any knowledge about who is listening to these events. Okay, like retail here just broadcasts the message that Alice has ordered a phone. Doesn't need to know is marketing is subscribing to it, is notification subscribing to it. No, it doesn't need to know. And because of that, it keeps them simple, the publisher simple, and it allows other services to consume these events without requiring any upstream changes. So one thing to remember, that your event design, like when you are building these event-driven architectures, your event design, it impacts your architecture. Like my story, I learned it the hard way in my career when I was getting started in and learning event-driven architecture. I did not really do this event designing very seriously and started building my system without doing a proper event designing. And that really made adding features at a later stage for me a nightmare. And then next time I learned from my mistakes on another project, we invested really heavy in event modeling upfront, like having these sessions and coming up with a proper model of the event schema that we would want. And it really paid off tremendously. Like the architecture was agile, adding new features were much easy. So what I want to enforce is, what I want to insist is that take that time to design events thoughtfully upfront. And don't get me wrong, I'm not saying that don't make mistakes. I am also a very firm believer of that you learn more from your failures than your successes. But I also think that the better way to learn is to learn from failures of others and succeed in your own. So now let's take a step further and understand how to build these event-driven architectures. And for that, let's take a look at how synchronous and asynchronous methodologies, they differ. Now, in synchronous architectures, the request, it flows sequentially through layers. Like, you have an API layer that handles the request, it passes it on to a computation layer, and then computation layer performs the computation, and at the end, like a storage layer is called. And each layer completes before the next layer is invoked. Whereas in an asynchronous thinking. Okay, we flip this around. Like the API layer, it receives the request and it stores it in storage. And then the computational layer, it reacts and operates independently. Okay, like the storage events, they trigger that asynchronous compute. So again, sharing my experience, asynchronous event driven thinking, it really requires a mindset shift. Okay, in the early days, I think when you're trying to understand event driven, it's not going to be easy to start thinking asynchronously. Like we are kind of all set to think in a synchronous manner, and making that mindset shift to start thinking asynchronously requires efforts. But then it only gets easier as you continue working on asynchronous patterns. So now, what are the benefits of thinking asynchronously or processing things asynchronously? Now, because we are doing store first, so the data is stored before it's processed. And this means that the chances of the data that is being sent by user being lost is low because you've already persisted it. And then the user can be instantly notified that their data has been received and is being processed. And they can later poll the results whenever they like. They can also request result multiple times. And because you process it later, the advantage of that is that if required, the data can be processed in parallel asynchronously. And then it can also be processed multiple times in case the process fails because you persisted the original request. So you can kind of process it multiple times if required. So overall, we can say that the main benefits that we see with event-driven applications are loose coupling. Your components are loosely coupled by publishing and subscribing to events. So it enables more, you'll see more modularity, you will see more flexibility. You will also notice architectural agility. Now, what I mean by that is that you will notice that it is more easier to evolve event-driven systems. Like, when it comes to adding new events, maybe adding new flows, components, etc., it's much easier. You see high throughput, we are doing asynchronous processing. So it definitely improves your overall throughput and performance under high loads, decoupled failure handling, because now your components are loosely coupled, your failures are isolated and they do not cascade across components. Okay, so it's also relatively easier to apply error handling, retries, etc. Dynamic scaling, components, you can kind of scale the components independently to match processing needs. And then overall, you will see a higher availability in your event-driven architectures. Now, so now with that, you understand this. When you start approaching event-driven architecture, and by that I mean when you start thinking event first, some common questions are bound to start from, like how do we identify and design events? Like I said before, a good event modeling is crucial. Then the next questions will come, like how do we build this event-driven architecture, and how can we scale these event-driven architectures? Well, all of these are very good questions, and let's take a look at them by looking at a real example. And so over the next few slides, we'll look at how an event-driven architecture allows us to scale and simplify a growing e-commerce site. Okay, now what you see on the screen, it's a standard synchronous API-based service. In this case, when a client makes a request to the checkout service, it has to make a downstream request to the order service. Once it gets a successful response, it can respond back to the client with a success message, like, provide a confirmation number, customer is happy, everyone is happy. And this works really great when you've got a nice, small, simple system like what you see. But what happens when you have to support a growing number of services? Like, let's imagine your store operations are growing. Like, what happens when you need to add the next service? Now, there's nothing wrong with having a lot of systems that are interested in data from this checkout service. what is problematic is that in an API-oriented design, the the checkout service, it needs to know about all the other boxes. It needs to know which are the services it needs to talk to. And, like everybody knows how great microservices are because they are decoupled and everything. But the checkout service, it still needs to know how to locate the rest of the endpoints. It needs to understand how to make those appropriate API calls and what to do if one of those calls fail. It still needs to have those retry logics. It needs to do the error handling. It needs to know the format of the data that the other services can understand. And this is exactly where an event-driven architecture can help make your system flexible, scalable, and reliable. So let's try and build this on cloud. Let's say Azure. One of the options that we will use is PaaS service, platform as a service, Azure Event Grid, whose main purpose is to route events from the checkout service to the appropriate downstream services. And this process will happen asynchronously as soon as the checkout services publishes the order created event to the event grid. Okay, now, so what will happen is the user, it creates an order, the checkout service creates an event called an order created event, and it publishes it to the Azure Event Grid. Now, the message that you see here, the event that you see here, order created event, it's a JSON file message containing all the details related to the order. But the important point to note here is that this event does not necessarily have to go to all of your services that have subscribed to your event grid. No, you can basically filter, like using Azure Event Grid, you can easily filter events and send only specific events to the downstream services, like based on your event attributes and data. So in this case, let's say you'll filter the event based on the event type attribute value, like in our case, it's order created. So only 3 services which have subscribed to the order created event type will receive that event. Okay, now you can also add an event store in the mix to improve the overall resiliency and scalability. Like, remember I talked about the store first approach? So this is where you're using an event store right after your API call so that your checkout service first persists that event in an event store. In our example, it is Azure Cosmos DB, before it is routed to the Azure Event Grid, from where the different subscribers can listen and react accordingly. So what this event store is doing for us is it is storing the records of all the events in a serialized form, and it is also serving as the source of truth for what has occurred. And because events are immutable, so the components, the different services can basically replay the events that have occurred in order to rebuild the state. So, this kind of helps with resilience because your components can recover by replaying events. And like if you want high availability, you can also have these event stores replicate these events for high availability, and your consumers can kind of independently catch up on these events. Like if they need to, then you can also do load balancing by adding partitions in the event store. So overall, I think what I'm trying to say is bringing a data store to store these messages before they are processed, it kind of promotes loose coupling, independent scalability, and all the other things. So the overall pattern that we saw looks like what you see on the screen. First, you have an API layer. It stores the data in Azure Cosmos DB. Now, at the back of Azure Cosmos DB, you have a feature called change feed trigger. That invokes an Azure function whenever any row is inserted or updated in the Azure Cosmos DB. So basically, whenever any event is inserted into the database, the Cosmos DB change feed trigger invokes an Azure function. That Azure function publishes the event to the Azure Event Grid, and then the Azure Event Grid routes those events to the subscribed consumers, and consumers react to these events independently. So overall, this pattern demonstrates how you can simply build and implement a robust event-driven system on Azure. Now, enough of seeing it on theory. Let's come and look at this in action through a demo. So for that, I am going to take you to, first of all, the source code where it's placed. It's placed in my GitHub account. I have the link of these resources shared later. I'll share that with you. And so this is the overall code. Let me kind of show you what the code is using VS Code. So the whole structure of the code is I have a folder .azure DevOps. Basically, this keeps all my CI/CD components, I think all my stages, my variables, my main pipeline, what it is doing. And then I have infra. And infra, you will see I have the bicep files for deploying the resources which are required in this event-driven integration, like Azure Function, Azure Cosmos DB, Azure Event Grid, Event Grid subscribers, etc. And then we have our source code, and this source code is basically I've coded it in .NET 8 and C# 11, and then it basically has 3 functions. The first one is an order create function, a very simple function. It's an HTTP trigger based function, and what it does is it's basically just accepting the order from the user, and it is persisting it in a Cosmos database. That's the only thing that currently this function is doing. And then back of it, we have a Cosmos DB trigger function. Now, what this Cosmos DB trigger function is doing is it's basically looking for a particular database container, a container in a specific database in Azure Cosmos DB account. And as soon as any row is inserted or updated in the database, basically this function gets triggered. And again, this is doing a very simple thing. It's a very thin-led function. All it is doing is it's taking the event from the Cosmos DB, and it is converting it into an event grid event and sending it to the Azure Event Grid. So this part is basically sending the event to the Azure Event Grid. And now once the event reaches the event grid, then any subscriber who has subscribed to that event grid topic will basically react and will receive the event, and it will react based on that. So I'll show you in the portal a little bit in a while, but this is the code of the subscriber. Again, kept it very simple just to kind of demo for the purpose of demo, that you have a subscriber which is processing that order. All it is doing is it's just receiving the order, the event data, and it is right now it's just logging a little bit saying the customer name is this and this is processed. Okay, so with that, if I take you to now Azure portal, first let's look at the pipeline. So this is the pipeline which has basically run, I've already run it. What it is doing is it's doing basically 3 to 4 steps. First, it's building all my .NET code, running any .NET test cases if they are behind the scene. Then it's validating my bicep files. Earlier, I used to have a step here which would convert my bicep to an ARM template, and only then you were able to validate and deploy your ARM templates. But now we have this new feature wherein you can directly validate and deploy your bicep templates inside it. So I've made that change. So right now we are validating the bicep templates. In this, you deploy the bicep templates. So when you run this pipeline and this stage is done, you will see your Azure Function, Event Grid, Cosmos DB, and other things coming up. And after that, once your Azure Function is Azure Function is deployed, you can then deploy the code, deploy the function code to it as well as deploy any subscriptions which are dependent on it. So this is the pipeline that looks like. Coming to our portal now. This is the resource group in which I have kept all the required resources for this event-driven. you can see we have a function app, which has those 3 functions, which are shown in the source code. Each function app needs to be hosted on an app service plan. So this is an app service plan, and there is a storage account associated with it as well. Other than that, there is Cosmos DB, Azure Cosmos DB, and you have an Azure Event Grid topic. And then for monitoring purposes, we have App Insights and Log Analytics. Now, taking you inside the function app. So let's look at the functions which are deployed to it. So you can see the 3 functions are here. This is the order create function. It's an HTTP-based trigger. We have Cosmos to Event Grid function. It's a Cosmos DB trigger. It'll convert the data stored in the Cosmos DB into an Event Grid event and publish it to an Event Grid topic. And this is the subscriber, which is listening to that particular Event Grid topic. And whenever any event is published to the Event Grid topic, then this will trigger and it will perform a function. Now let's look at this in action. For that, let me just enable the log stream. You can also look inside App Insights and Log Analytics to validate your what has happened in when you run your application. But this will kind of show live action as to whenever we run it. So now let's go and try and create an order. So for that, I am using Simple Postman. I have a post request. You can see it is invoking the order create function. This is a very simple body that I have. I have implemented AD authentication. So I'm going to generate a new token, and I'm going to use that token, and I'm going to invoke my send request. Now, what will happen is, yeah, okay. So we can see we received a 200 OK here, but now let's see what has happened behind the scenes. So what has happened is the minute we invoke that API request, right, for order creation, basically it invoked the order create function, was listening, like it was an HTTP trigger. So it picked it up and it basically went and persisted the row in your Azure Cosmos DB. And the minute you kind of, the row was persisted in Azure Cosmos DB, our Cosmos to Event Grid function basically picked it up. The Cosmos DB trigger picked it up because it identified new changes on container event at so-and-so time. The Cosmos DB trigger was fired. You received one document, and then very thin-layered function, all it is doing is it's converting the data from the document into one event, Azure Event Grid event, and it is sending it to Azure Event Grid. And it finished the function. And as soon as the Event Grid topic received the event, basically the process order handler picked it up, the subscriber. Now this is the subscriber part. It picked it up, and you can see it just simply received and processed some part of the data. Now let's take a look at Event Grid topic to kind of see whether it did receive the event or not. So we are looking at last 1 hour. I think we'll have to give it a little bit of a time for it to come in. Otherwise, in the published events, I should have seen one. Let's go inside this. So you can see here, right, your event subscriptions. So this is your event subscriber. And let's do 1 hour again. And you can see that it is attached to your process order handler. So this is why when I said your process order function is basically the subscriber, this is what I meant with it. And yeah, I think we can see here very clearly that basically this was delivered. So you can see that we have one event which was delivered and one event which was matched. Now, when a match usually happens when your subscriber is looking for a specific type of event and it gets that specific type of event. So that's why your match count is 1. And delivered 1 will come only if it was able to process it correctly. So in case if there was any error in your process order handler function, then this delivered would not have come correctly. And what the Event Grid topic would have done is, if you have configured these additional features of retry attempts and what if you've enabled del letter, then what the Event Grid topic would have done is it would have attempted to deliver it again and again. based on the exponential time off and the configuration that you've done for retry. And after a certain number of retries, which is configured, it would have then, if your dead letter is enabled, it would have pushed it into a dead letter, so that if you later want to reprocess it, it's available for reprocessing. So hopefully this makes it a little bit clearer as to what happened, like how did we build a very simple, loosely coupled event driven system. Okay, and with that, I'll come back to our slide. Yeah, and what we'll do is, like right now what we saw was a very simplified event driven architecture, but let's take a look at some of the best practices and considerations when you're building event driven architectures. So yeah, event storming, right? Like you all would have heard of event storming, but how many of you have actually been through and done an event storming workshop? Now, I won't go very deep into event storming, as probably it's a separate topic for some other day, but let's quickly touch upon what event storming is like. So when you run these event storming workshop style modes, right, you basically get every single possible stakeholder in a room together, like your business people, your technical people, everyone is there together, and everyone has this pack of these post-it notes, and they're all sticking these post-it notes on the wall, sticking these post-it notes to kind of understand what are the events that are there in a system, like things like has the order been created? What happens when the payment is initiated? What happens when an order is completed? So basically, this is, more importantly, it's like a conversation focused on the business. And what you get out of an event storming session is one common language that you're going to use across the entire business, both in technical and the non-technical. And that's the core part. So when you are doing event-driven architectures, make sure you spend time doing event storming. And like quoting directly from the website, it is the smartest approach to collaboration beyond siloed boundaries. And it can also be used to highlight architectural boundaries to allow robust and flexible evolution, and also design clean and maintainable event-driven software to support rapidly evolving businesses. So like I mentioned, like I keep on reiterating it, but spend your time upfront doing event storming, and after that, moving on to the event modeling as well. So coming to the next consideration, changing the event schema. So another thing that you should account for earlier in your design journey is like what happens if there is a change in the event schema. So imagine that you've built this amazing event-driven system, and now for some reason, you need to change the schema of this event. Like, let's say you need to add a new field to the schema. Now, who can see a potential problem with this kind, right? Like, you've actually broken the contract of your event. You have changed the schema of the event. And now you would be probably thinking, okay, so what do I do now? Or how do I handle this? So what you should always do in these cases is whenever you're building an event-driven system, adopt some kind of a consistent schema with your events. Like, there are actually consistent specifications that exist exactly for purpose like this. Like, you have cloud event schemas, you have event grid event schemas. So basically what I'm saying is you should have a defined specification for what an event should look like. And you'll see there are really few important properties in here. Like, first is the data section. Now this data section, it's that actual event payload. And this is what is going to be custom in every single event across your entire system. Okay. But other than the data part, in the metadata section, you have this ID property. Now this ID is basically a unique generated identifier that is generated at the point of publishing your event. And this basically allows your downstream downstream systems to implement things like idempotency. Like they can look at an event which is coming to their system and look at its ID property and say, hey, I've seen this event before. So maybe I can drop it. Maybe I can ignore it. So, and bringing the conversation back on breaking changes, like around evolvability, like you have the source field, which tells you where this event has come from. You have a type property, event type property, which tells what type of the event it is. And then, like similarly, you can also add other properties to it. For example, you can add a version property. And what that version property will allow you to do is basically, if there are any breaking changes, it'll allow you to implement or introduce those breaking changes in a real safe way. Like, so maybe like at a minute right now, you are publishing version 1 of this, let's say, order confirmed event, and you want to introduce another breaking change in the schema. So what you will do at this point is you will not overwrite your version 1, but you will publish a version 2. And basically, you'll give the time for your subscribers to move from version 1 to version 2 smoothly without causing these breaks. So that's why, like I said, it's very important to design your schema well. Next, let's take a look at eventual consistency. Now, this is one of the trade-offs that you have to make when you are building these distributed applications, event-driven systems. And what you need to do is you have to embrace this eventually consistent way of looking at the system. Like, it's not going to be consistent at the start, but eventually it's going to become consistent. And now I'm not going to go into details here, but I'll definitely suggest that I gave a complete session on how to build these eventually consistent event-driven applications April this year in the Microsoft Azure Cosmos DB conference. It is available on YouTube. Happy to share the link if someone is interested to see. But this is again something that you need to handle when you are building distributed event-driven systems. And then coming to observability. Yeah, I think observability is really important in every single kind of system that you build, like irrespective it's synchronous or asynchronous, because you need to understand what is going on inside your system, okay? But with an event-driven system, it really gets tricky to understand the cause and effect. Because let's say you are in a request response model, right? In an API-driven model, you have a service A that's calling service B, and then the service B responds back to service A. So you can kind of see what's happening there. But in an event-driven system, you're basically just publishing an event, and at some point, someone might be interested in consuming that event. So you want to keep your system observable. You want to be able to understand the cause and effect. So this decoupled nature of the system, where services communicate indirectly via events, it makes it really hard to correlate and trace the flow of data. And one easy way that I suggest to do is like using a correlation ID in the event data. So remember the metadata that we saw of the event. So in the metadata section, you can add a correlation ID. This is again nothing but another uniquely generated identifier, basically to keep track of the flow of the data. Okay, so it allows you to continue that trace. It allows you to link the traces together, and it allows you to understand the cause and effect more easily. Of course, like in your consumers, you will need to handle this fact that it may happen that maybe the trace doesn't exist anymore, but at least it potentially gives you the possibility to determine the cause and effect. So like, again, I think it's at the end, it's all being intentional with how you design the schema of your events. What are the things that you're thinking of? Are you thinking of observability? Are you thinking of being able to track how your data is flowing across these events? Are you thinking of breaking changes? How do you introduce versioning, etc.? And then, lastly, coming to this, that, the system that we showed you, I showed you for building your event-driven architecture basically uses Azure Event Grid, but there are different PaaS services in Azure that you can use, and they all have different purposes. For example, you have Azure Service Bus. Now, it's a very robust enterprise message broking service, supports queue, topic, sessions, etc. Event Grid, we already talked. It's a fully managed event routing service, great for integrating events across services and applications. You have Event Hubs. It's a high throughput data ingestion service used for streaming millions of events per second. And you have your simple Azure queue service. Your simple message queuing service provides asynchronous decoupling and resilience. Now, what I want to say here is that each service, it basically caters to different type of workloads, like Event Grid, Azure Event Grid, use it for event distribution. Azure Event Hubs for high volume streams. Queues, like for buffering. Azure Service Bus, for complex workflows. And you can actually use other PaaS services like Azure Functions, Logic Apps to develop these event-driven apps. So by combining these asynchronous event processing services, you can basically build these reactive, scalable, resilient architectures on Azure. So with that, we come to an end of today's session. To wrap up, I will reiterate on these 3 points. Definitely embrace event-first thinking. Whenever you start designing a system, have this event-first thinking, and then model events upfront to enable decoupled components. Then store first, then process. Okay, and for that, leverage your event stores for resilience and independent scalability. And with that, you will be able to build these scalable, resilient applications using event-driven architectures and unlock responsive and adaptable systems. So as promised, here are the resources. There's the full source code, which I have uploaded on my GitHub. It's here. And there are a couple of great learning tutorials and articles from Microsoft Learn. So please make sure you take a look at them. And I'll probably open it up for questions, if any. And reach out to me if you have any questions. Otherwise, also please reach out to me on LinkedIn. Very happy to have a chat about event-driven architectures or even Azure in general. So yeah, thank you.
Yeah, thank you so much, Teena. It was really great. The information that you shared with us was so invaluable, because for any type of project, people that you are going to implement in your environment, these information that Teena shared with us are pretty much critical, because you need to consider all of those aspects that she just explained it to us. So thank you so much, Teena. We have several questions. I'm going to start from the oldest to latest. So we have Martin question here. What Azure services are most effective for building event-driven serverless applications?
I'll suggest it all basically depends on the exact use case scenario you have. I think what is the data that you're looking at? What kind of communications are you have in your system? I think the overall business areas as well. But like I shared in my screen, my presentation earlier. In fact, let me come to it. You have for messaging and event-driven systems, you can basically make use of these services. Azure Event Grid is definitely my top choice in these cases, because it acts like an event routing service, and you can have multiple topics. You can have multiple Event Grid namespaces as well, so it can kind of takes care of the different sources in case if you have and you want to listen to different sources from different sources. But then if you're looking at really high load, then I'll recommend Azure Event Hub, because it's a very high throughput data ingestion service. So again, I think my answer would be probably it depends.
Yeah, exactly. I think you already answered some of this question, but just showing up them here to if you need to add something more. So how does Azure support the scalability and reliability need for global applications?
I think like Azure, basically when you're building these cloud native services, and when you just using Azure doesn't guarantee scalability and reliability. When you're utilizing these cloud native services, which provide us the scalability and reliability. So when you start building your applications, depending on the requirements of your application, you can implement scalability and reliability. Like there are a lot of PaaS services which automatically have scalability with them, so you can kind of scale your applications using the dynamic scaling capabilities provided by these services. Like, you can use different services like Azure Front Door or like your load balancers, your traffic managers, to kind of load balance your data and scale to different regions if required. And then reliability, yeah, you can implement, again, a lot of these PaaS services, they come with inbuilt reliability. We took a look at Azure Event Grid. Now, in case if Azure Event Grid is not able to, your subscriber is not able to process the message which Event Grid is trying to push to it, then you can kind of build in the resilience. You can build in the retry capabilities so that it automatically retries specifically those network kind of errors, those transient errors, and it can kind of retry and then successfully process it in the second time. So probably I'll say that if you're configuring your application correctly and you are making use of the services which Azure provides you, you can kind of scale and build your applications reliably.
Yeah, that's a very correct answer, because many people, I'm not saying the most of them, but some of them, thinking that having these kind of services inside Azure Cloud, it's just like you have all scalability or reliability services on top of that, but it's not true. Basically, you need to create the service, and based on your need, add more features or use more features that you can have based on the service. It's related to, maybe sometimes you need to go through some security, enable some security options as well. So basically, the default version, it's always in cloud, but it's not following all of the scalability or reliability needs for your organization. So that's the perfect answer. We have another question from Martin. You already answered this one as well. You showed us some QR code related to the learning things. It would be perfect if you back to that slide as well, so people can scan the QR code.
Yes. I think the demo that I showed is a really simple event-driven service. I always like knowingly I keep it really simple, because once you understand how to use these components correctly, then you can add the complexity and based on your requirements. But yeah, simplest are these services.
Exactly. So we have a question from Aaron Kumar. How can event-driven architect be effectively implemented across two different organizations, especially when one is a third-party vendor? What Azure components can facilitate this integration, and how can we ensure the solution is secure, reliable, and resilient?
Yeah, very, very good question. Basically, if you want to attempt to implement this event-driven architecture across different organizations, like it again, it depends which services are you using and what is your rationale for using these services. Like if it's imagine if it's just a synchronous system and you want to make it into an asynchronous, like you can just put a simple messaging service in between, a queue, a simple queue, storage queue, which will act as a buffer to kind of receive the messages from the other system, so that and then it can process it at its own sweet time. So basically, you are building loose coupling. Like right now, I'm just talking about loose coupling in this case. But if you really want to go and understand and like do more things, I can give you my personal example. In one of my previous organizations, we had a third party, and we wanted to do a asynchronous communication with them. They were hosted on AWS. We are hosted on Azure. So we kind of used Azure Event Hubs for our communication, and they had Kafka at their end. And so there was a requirement to build an adapter in between. And what would happen is when the message would come from their Kafka, like they would push the message the adapter, and the adapter would basically push it into our event hubs. And once it has reached our event hubs, then we can basically do whatever we want to do with it. And vice versa, when we had to send something, our events to the third party, then all we had to do was we had to push our events to our Azure Event Hub, and there adapter would be looking at was connected to our event hub, and it would take events from our event hub and push it to Kafka. So I'll say it depends from scenario to scenario, but the main point that I want to say here is introduce that kind of a loose coupling between them. If you will do a direct API to API communication, then you're basically in a request response mode. In order to implement event driven, I think the first foremost, try and build a simple loose coupling between them, whether you use message queues or you use event grid, event hub. I think that all depends on the scenario then.
Yeah, that's true. Perfect. Yeah. We have the last question here from Martin. We are in process of building a solution on Azure, possibly using Azure AI Studio, where our members can upload their resume or CVs based on PDF document. Is it possible to modify the process midway? Especially, can we use Python programming to convert the PDF document into a JSON schema as part of the workflow? Does Azure allow us to implement such a step?
Okay, now this is something that I haven't tried, but remember in between I talked about those function layers, right? Like once you store your document into a data store, and then you can have a Cosmos, like, just again using my same example, imagine you're storing your PDF, your CVs or PDF documents in Azure Cosmos DB, and then you can have a Cosmos DB trigger function based out of it. And in that function, then it's your world, right? However you want to convert it. I think the ultimate aim then is to convert it into your event. And I haven't tried it, but probably even in our event, we can have, we can convert and process it later. So I would recommend giving it a try by using an Azure function component in between and seeing the transformation that you want to do, if possible.
Yeah, I think one of the best way to do this kind of solution, having a kind of bridge between these two systems, like Azure function that you just mentioned, it's the best way to have a process between these two services. So I think that one would be a good solution, to have an Azure function middleware. Okay, cool. As far as I can see, we don't have more questions, but based on our promise that we have for all of the sessions that we have, you need to choose the best question. So we are going to give that person a 50% discount for Microsoft exams. So yeah, which question was the best one if you are going to choose?
I think all questions were really good. I think I related more with the two organizations. How do they do event-driven communication? But then again, I said, like, all questions are great.
Yeah. That's true. We have really good learners that they are coming with a very great questions. Sometimes, those questions bring us something on table that we need to think about that and go and investigate and see, what is the exact answer for this kind of question. So we have to say thank you to learners as well for these kind of questions. So perfect. So Aaron Kumar will be our winner in this case. So Aaron, we will contact you by email. We will send you the voucher. Congratulations. And yeah, if there is no more question, I think it's time to wrap up the session. Perfect. Yeah. Thank you so much, Teena, and hope to see you on our stage very soon. And thanks again for all of great job that you are doing in the community and for Women in Tech. So thanks again.
Right back at you, Saeed. Very happy to see all these community initiatives. And now, oh my God, the in-person event. That's going to be fantastic. Really looking forward to all of these few things.
Thank you so much that you mentioned it. We recently, for those that they haven't heard about that, but we recently shared news regarding seeking for sponsorship. We have a in-person plan for 2025, which is going to be crazy, I would say. So that's a really good news, and I hope we get some good sponsorship together with Microsoft, who is going to sponsor us as well. So let's see, maybe we can see each other in person event at Microsoft Zero to Hero. Why not?
Definitely. Yeah. Congratulations for the event, and really looking forward to it.
Yeah, thank you. Me too. So perfect. Thank you so much again. We've got some thank you, and people, was so happy about the session that you presented today on our stage. And wish you a great weekend. Take care, people. Don't forget to register for the other sessions. We have 2 sessions left for next 2 weeks. So make sure that you register for those sessions. Let's support each other. Let's learn together in the Microsoft Learn way. Have a good one. Take care.
Cheers. Bye.